All right, today we're going to go over rational transformations. Before we get started with that, we really want to go back and think about those rational parent functions. And there were two here in the rational unit. There was the rational even and the rational odd. So we'll go ahead and start with rational odd. And that was y equals 1 over x. That graph had two pieces, one in the first quadrant, one in the third quadrant, look like this. It had a horizontal asymptote and a vertical asymptote here, and it had the points at -1, -1, and 1, 1. Those are really the key points that we're going to use with transformations, so it's important to know those. When we did the domain and the range for this function, we talked about how it came from the left-hand side, got really close to the y-axis, and then it jumped over it and continued forever. So our domain would be all real numbers except for that 0. Same thing's happening on the y here. It's coming from way on the bottom, gets really close to the x-axis, then jumps to the other side and keeps going up. So our range would be all real numbers except for y being 0. I'll go ahead and put those key points right here. We said we've got a point at -1, -1, and 1, 1. So those are the key points that we're going to look for when we graph. The other key points are really the horizontal and the vertical asymptote. And so we'll refer to that as HA and VA. The horizontal asymptote is the x-axis, so that's y equals 0. The vertical asymptote is the y-axis, and that is x equals 0. Our other function is 1 over x squared. That's our rational even function. And it looks like this. Both pieces are up on the top. So we've got a piece on the first quadrant and a piece on the second quadrant. Our key points are similar. That's going to be 1, 1 and -1, +1. So I'll go ahead and put those real quick here. -1, +1, and 1, 1. With that being squared, all of the values that we had on the negative here came up to the positive because a negative times a negative is a positive. Our domain is the same. It is just jumping over that y-axis. Our range, however, is all on top. So we would say y is greater than 0 or from 0 to infinity if you're using the interval notation. Now there is not an equal sign there and it's not a bracket, it is a parentheses because this graph never touches 0. So the y value will never be 0. And our horizontal and vertical asymptotes are the same. We've got one at y equals 0 and one at x equals 0. Now, for our transformational form, the a value would be on top, the b value would be on the bottom, and then our d value would be out to the side, like this. That's for the rational odd. For the rational even, the only difference is that square. Quick reminder from those transformations from earlier this year. The transformations are the same for every single function all year long. Once it's in the transformational form, that A, B, C, and D do exactly the same thing to each and every graph we deal with. So we've done quadratics, we've done absolute values, we've done cubics. We are now doing the rationals. And again, the A, B, C, and D do exactly the same thing for every single function. It takes the parent function and it moves it a certain way. So before we get started, I do want to quickly review those. So let's do that. All right, so what we're looking at is our table here of those transformations. That D value on the outside, we'll start with the easiest one. That's the easiest one. The D value on the outside causes a vertical shift up or down. So if it is +2, it is going to go up 2 units. That means you're going to take your parent function and move it up 2 units. If it is -d, then it is going to go down 2 units. If we've got the x minus c, that's the part inside of the operation. In this case, that means it's in the denominator with the x. If that is x plus 2, it is going to go to the left 2. If it is x minus 2, it would go to the right 2. The a value is when it's being multiplied across the front. So you'll see that on the numerator most of the time or in front of the fraction. If a is bigger than 1, it causes that vertical stretch by a factor of a. If it's between 0 and 1, then it's going to cause a vertical compression by a factor of a. And if the a value is negative, it reflects it across the x-axis. Now for the last one, which is the b, and again, that's inside of the operation. So it's going to be inside that squared part, and also with the x in the denominator. If b is greater than 1, it is a horizontal compression by a factor of 1 over b. So to get the scale factor there, you have to do the reciprocal. You got to flip it. If it's between 0 and 1, it's a horizontal stretch by a factor of 1 over b. These are hard to differentiate, the a and the b, in the rational functions, so keep that in mind. The b is less than 0, so if it is a negative, then it is going to reflect across the y-axis. Again, a little bit hard to see on these types of functions, especially the rational odd. And that is because you've got a piece in the first quadrant and a piece in the third quadrant. So when you reflect across the x-axis, it looks very similar to the reflection across the y. In fact, those are the same. So you just have to know what part of the equation it's in. All right, so down here, I'm going to put the ones that are really important. We talked about a being greater than 1. That is a vertical stretch by a. A being between 0 and 1 is a vertical compression by a. And a being less than 0 is a reflection across x. That means if you find that in this place right here in the numerator, if we find a 2 here, it would be a vertical stretch by 2. Vertical stretching, remember, that takes it from the top here and we pull it this way. So our 1, 1 would get further from that origin. X minus c goes to the right c. X plus c goes to the left c. That means we would pick up the entire graph and move it to the right or left. And then the plus c goes up and the minus d goes down. All right. This is going to be one of the harder functions that we transform because of the way it operates. So when you move this to the right or left, that means we're picking up this graph and we're moving it right or left. If you think about that, our horizontal asymptote that goes this way, if it moves right or left, that doesn't change anything. But if it moves up or down, it is changing. Same thing with our vertical. If it moves up or down, that doesn't change that line. However, if it moves to the left or right, that does change that vertical asymptote. So when we think about this vertical and horizontal asymptote, these transformations are going to move them. So we said when it moves to the right or left, so that's that C value right there, right or left, it is going to change the VA, the vertical asymptote. The D value, that's the one that moves it up or down, that's going to change your HA. So keep that in mind as we move forward to graph some. And we'll start with some easier ones and then move to some a little bit more difficult. So let's try one. All right, we've got y equals 1 over x plus 5 here. That plus 5 at the end there is up 5. Because that is the D value. It's not inside the operation, it is on the outside. So that's our D value, so it's going to go up 5. That means we're going to pick up that graph and we're going to move it up 5 units. So if our horizontal asymptote was at 0, it was right here, we're going to pick it up and we're going to move it up 5 units. So here is my new horizontal asymptote. And horizontal lines are y equals. So our horizontal asymptote would be at y equals 5. This has not moved left or right, so our vertical asymptote will stay the same right on top of the y-axis here. And vertical lines are x equals. So our vertical asymptote is at x equals 0. Now we do the same thing to our points there. The point that was at 1, 1, we're going to move it up 5 units. So it's going to be right here at 1, 6. And our point that was at negative 1, negative 1, it's going to move up 5 units, and it's going to be right here at negative 1, 4. Now what asymptotes do is guide your graph. So your graph is going to move towards those asymptotes. So when you graph, you move it towards those asymptotes. And there is our graphs. We have graphed our rational equation. Now we said when we move up, it changes the horizontal. So keep that in mind as you're writing the equations of the asymptotes and as you are graphing these. Now for our domain here, it is still all real numbers except for 0 because our vertical asymptote is still at x equals 0. That's still what it's jumping over. For our range, it's coming from the bottom and jumping over that 5 and then keeps going up. So our range would be all real numbers except for 5. All right, we'll move to one that has a little bit more transformation. So we're going to go over here to the second one. There we go. This one's got 2 transformations. It's got a C and a D. So the D value, we said that's going to go up 1. This C value is going to go to the right 2. So this one's got 2 transformations. It's going to change our graph in 2 different ways. We said the C and the D are the ones that move the asymptote. So that's really important. That's where we want to start our graphing from. So right 2 would change the VA, and up 1 changes the HA. So that's what we're going to graph first. We're going to pick up our horizontal asymptote and we're going to move it up 1 unit. So here is the new one. Then we're going to pick up our vertical asymptote and move it to the right 2 units. So it is going to be at x equals 2 there. Remember, with vertical and horizontal lines, you must write that x equals and y equals. So vertical line is x equals, so the vertical asymptote is going to be x equals, and that x value is 2. Our horizontal asymptote is y equals, because horizontal lines are written as y equals, and it is going through that point 1, so that would be y equals 1. We're going to do the same thing to the points. So the point that was at 1, 1 is going to move to the right 2 and up 1, because that's our transformations there. The point that was at negative 1, negative 1 is going to move to the right 2 and up 1. And then we're going to move them towards the asymptote in order to graph. So for our domain, we have all real numbers except it is jumping over 2. And for our range, we have all real numbers except it is jumping over 1. Notice that your horizontal asymptote is part of that range and your vertical asymptote is part of that domain. That is always going to be true there because it is jumping over that asymptote. That's what it's getting close to. It does not touch that asymptote. It is just being guided by that asymptote. That's what the asymptotes do. Now we've done it by hand now to graph it, but I do want to show you on the calculator what that looks like so that you can be familiar with the calculator version of it. So I'll go ahead and put our calculator here. This is the same as if you use Desmos on the computer, TI-84. Really any graphing calculator should work for you on that. So if we did 1, to get that exactly the way it looks on your paper here, you hit alpha, y equals, and that's going to put it as a fraction with the numerator over denominator. And so I put 1 and then x minus 2 and a plus 1 on the outside there. Now when I hit graph, we get exactly what we saw on our paper there. You can see the vertical asymptote is right here. That's guiding our graph. You can see the horizontal one that is right here at y equals 1. If we go to our table of values here, you are going to see that most of the points are fractions because they are getting smaller and closer to that asymptote. We do see the point though, 3, 2, which is the point we got right here, and 1, 0, which is the point that we got right here. Notice that at 2 it says error. We knew that because it's jumping over the vertical asymptote there. That error is our vertical asymptote. You're going to see that because that is where it makes it 0 in the denominator. 2 minus 2 would be 0 here, and we know we can't divide by 0. So that's why we see that error there, and that is the reason why it is jumping over that point. All right, this next one we're going to look at here is not the rational odd, it's the rational even because it's got the squared term there. So our parent function is the rational even on this one. That's important because you remember you want to take that parent function and move it so it's going to have the two pieces on top and not the piece in the first and the third quadrant. All right, the only transformation we have here is that 2. That's our a value, so that's going to be the vertical stretch by 2. That means that our asymptotes are not going to move because it is not moving left to right and it's not moving up or down. So our asymptotes stay right where they were in the parent function. So we've got one at y equals 0 and the other at x equals 0. It has not moved. So I'll go ahead and write that. Our vertical asymptote is x equals 0. Our horizontal is y equals 0. Now what changes is our graph. We said a vertical stretch looks like we took it like this and stretched it up. So the point that was at 1, 1 would go up to 1, 2 because it got stretched by 2. So I've doubled where it was at. The point that was at, -1, +1 is also going to go up to -1, 2. We have stretched it by 2. We took it and doubled it this way when we're stretching. And now we move towards the asymptotes. And there's our graph. It is further from the origin. That's what that vertical stretch does. It's going to stretch that part there so that you have a bigger gap right here. That's how you see a vertical stretch, is when that gap has increased. Now, that does not change the domain because we still only just jumped over that vertical asymptote at 0. And all of our points did get close to the x-axis and then move up. So our range is still y is greater than 0 or 0 to infinity when you're working with the interval notation. Either one of those is acceptable. All right, we're going to go ahead and graph one more with more than the 1 or 2 transformations. So we've got this right here. The first thing I would want to do is factor out that negative. Make sure that everything is in that transformational form. So when we do that, we end up with x minus 1. So that's important because if you look at it this way, you're going to say, oh, it went to the left one, but it did not. It went to the right one because the negative has to be factored so that it's in that correct transformational form that we talked about, this one here. It must be in this format. There shouldn't be anything in front of that x. Now, where that negative is, that would be in the place of the b. So that's a reflection across the y. If it was in the place of the a up here, it'd be a reflection across the x. Now, because of the way this function works, symmetry across the x and the y-axis is the same. So you're not going to see a difference from the graph itself. This right here would be a vertical stretch by 3, since that's in the place of a and it's bigger than 1. And then this one would move it to the right 1. So we've got 3 different transformations here. My first transformation to graph should still be that horizontal and vertical asymptote, and that is moved by the right one. So our vertical asymptote is going to move to the right one. Our horizontal one is not going to move since it is not moving up or down, so that's still going to be right here at 0. So vertical is at x equals 1, Horizontal is at y equals 0. Now we're ready to graph the rest of these points. So the point that was at 1, 1, I reflected across the x-axis, the y-axis. Here we go. We stretch it by 3, and then move it to the right one. So it's right here at 0, negative 4. Whoops. Sorry about that. The point that was at 1, 1, I reflected it twice. I apologize for that. Let me start again. The point that was at 1, 1, I reflect across the y-axis, and then I stretch it by 3, and so it should be, and then move it to the right one. So it should be right here at 0, 3. I got a little bit of. All right, so again, at 1, 1, we reflect it across the y, we stretch it by 3, and then we move it to the right one, and so there's our point. And again, I made a mark by mistake there. Our point that was at negative 1, negative 1, we reflect across the y, we stretch it by 3, and then we move it to the right one. At that, so we've got that point at 2, negative 3. Now we're ready to graph towards the asymptotes. So we just move our graph towards the asymptotes there. Since this is a vertical stretch of 3, it's going to be even further from our points there. So we'll have a bigger gap there. That's what that vertical stretch does, is create that gap there from pulling it vertically this way. So our domain is all real numbers except for 1, which is that vertical asymptote, because that's what it's jumping over. And our range is all real numbers except for 0, which is that horizontal asymptote that it is jumping over. So now you should be able to graph without a calculator using those parent functions. I want to show you how to work backwards and write those equations from the graphs. For the first step to do that, you're going to determine which parent function. So looking at that graph, decide, is it y equals 1 over x, or is it y equals 1 over x squared? Then you want to look at the vertical asymptote. That's going to give you your right or left movement. Then you look for the horizontal. That's going to give you your up or down movement. And then for that a value, you're going to find it by plugging in. So that's what's going to help us graph these, write the equation of the graphs from the transformations. First and most important step is determine which one of the parent functions you're dealing with. Then look for those vertical and horizontal asymptotes, because that's going to give you the C and D. And then you can solve for the A value. Coming from a graph, we usually just do the A value. We don't do the B value. Again, you could get a B value that would work the same way by solving, but A value is the one that we usually use with these functions. All right, so this first one that we have here, looking at this graph, I know that the parent function is y equals 1 over x. That's the one that has one piece on each side there. Looking at number 8 here, that one I know the parent function is 1 over x squared because it's got both pieces on the same side. So that's what you're doing when you're looking for the parent function. It's got one piece on each side, so I know that it's got, I know that it's the 1 over x. Now we start looking for the vertical and horizontal asymptote. Our vertical asymptote is going to be that line that guides your graph. So when we look at this, it is going to be right here. That is my vertical asymptote. It's at x equals negative 4. That means that my graph was moved to the left 4. That's important when you start to write the equation. Now we look for our horizontal asymptote. Again, that's the one that guides our graph. So we're just looking for where the end pieces of our graph are there, because that's going to tell me where it's at. When we looked at the calculator earlier, you saw that the asymptotes aren't actually drawn on there in a calculator or on a graph like this. So I went ahead and drew them in just so that I can see where it's at. But that's my horizontal asymptote at y equals 1. So I know my graph has moved up 1. Now that I have those two transformations, I can go ahead and write my equation, and I can just put in an a since I don't know that yet. Since it moved to the left 4, I know that that's x plus 4 on the bottom because that's what makes it move to the left 4. And then I need a plus 1 on the outside because I know that's what makes it move up 1. Some people are able to see the distance from that and find if there's a vertical stretch or compression there. Like you can see that the graph, instead of being in this quadrant and this one, it has flipped, so we know there's a reflection there. And really, it's only 1 unit and 1 unit, so there's not really a stretch or compression. That's the way you would get it from a graph. But again, you can plug in a point and solve that way. So we can plug in our -3, 0 here. I plug in the 0 for the y and the -3 for the x. And then we're going to solve for that a. So I simplify that bottom, and that is just 1. We're going to subtract the 1 to get it to the other side, so we get -1 is equal to a. So my equation would be -1 over x plus 4 plus 1. So that's how you write the equation using those transformations. You work backwards, starting with those asymptotes, and then plug in a point to find that a, and that allows you to write it. The same is true if you work on a table. So looking at this table here on number 7, we see the error, so we know that this is the vertical asymptote. To find the horizontal, you're looking at these values here. It goes -2/3, -1, -2. So you're looking for what it is getting closer and closer to. Since that is moving towards 0, -2, -1, -2/3, this side it's going 2, 1, and it's getting closer and closer to that 0, then we know that the horizontal asymptote is at y equals 0. So we would start our equation by putting in an a, and then x minus 2. Because our vertical asymptote is at 2, we know that it's gone to the right 2. And now we're ready to solve. You can take any of these points and plug them in. So I'm going to go ahead and plug in our 4, 1. So I plug in 1 for the y and 4 for the x. I would cross multiply here, and I get a is 2. So our equation is 2 over x minus 2. Of course, you can check your work, so you would want to put that into your y equals and make sure that table matches. All right, so that is transformations with rationals.